All right. All right. I see everybody's starting to come in. Hey, Shruti. Hey, Sunil. How are y'all doing?
Pretty good.
Hey, hey.
Good, good. Yeah, we're waiting for a few, we'll wait just about a minute or two. Uh, so everybody have a good weekend? I guess it's the middle of the week now. Has everybody had a good week so far? Hey, Shruti, how's your week been?
My week has been really good so far. Thank you, Chris.
Very
I
good.
feel like it's already been 5 days in, but we're only on Wednesday.
That's right.
Is
Uh,
it is it only is it only Wednesday? Because I'm ready for Friday though.
I know.
It's
I've got a travel day on Friday, and so it feels like, yeah, my Friday's actually tomorrow, so I'm all ready for that.
Where are you headed, Chris? That's cool that you're
We're
traveling.
going up to Colorado. I'm actually going to work from Colorado next week, so excited. It'll be my first week working up there. So fiber in the mountains. So we'll see how fast that is.
get that mountain
Cool.
air. Pretty
That's
good.
right. Get out of this halfway Texas heat and humidity. So, all
Yeah.
right, very good. I think I see everything looks good online. We've got people joining, and let's go ahead and let's get started with our meetup. All right, I'd like to welcome everybody on today to our CDP on Azure meetup. This time around for this chapter, we're going to be doing industrial data engineering. And my name is Chris Van Dyke. I'm a principal SE here at Cloudera. I've been here almost 4 years. I've been in the big data industry for quite a while. Uh, for everybody out there, as you're going to see from my twang, I'm from Texas, so there'll be a lot of y'alls as I'm talking today. And I'm actually coming to you from the middle of Texas in College Station, which is home to Texas A&M. Today we're going to be talking talking about data engineering, in particular how data engineering workloads can take advantage of the cloud and how these jobs can be supported to go into production. Our presentation today is going to be live streamed out on LinkedIn, Twitter, and YouTube. Questions will be monitored and answered as we go. So today, we want everybody to be active as possible, and we are going to be doing a raffle later at the end of the show today. Everybody that participates in the chat will be entered in the drawing. Please ask questions often. We've got 2 prize packs with some Cloudera swag that the winners will be getting. We'll do a random drawing at the end, kind of Wheel of Fortune style, and you must be present to win. All right, so I've already introduced myself. I've got a couple stars here with me today for the show. Let's go ahead and do a brief introduction for them. Starting from the far right, we've got Shruti. Shruti, introduce yourself, please.
Hey, Chris. Yeah, Shruti. Nice to meet you. Nice to meet the rest of the crew. I've already met you, Chris. So I've been here at Cloudera about 3 years and 9 months exactly, according to LinkedIn. And I've been doing this from Germany the whole time. So I'm originally from North Carolina, as you can tell with my accent, but I've been living in Germany and working for our Central European customers. So it's pretty nice to kind of do a meetup with you guys here again.
Very good. Awesome. And then from one of my in the middle here from Texas, I have Sunil. Sunil, go ahead and introduce yourself.
Yeah. Hi. I'm Sunil Manji, a principal engineer here at Cloudera. I've been around the space of data processing since the Apache Nutch days, so I've definitely outstayed my welcome in the industry. And I'm in Texas, though I don't have any accent like Chris because I am originally from Beartown, which is Chicago. So thanks for having me, Chris.
Very good. All right. Well, kind of to get started today, I guess for y'all, what is the role of data engineering in big data today? Shruti?
Yeah, so I think last time we were talking about this, I went on quite a drift. So I'll try to keep it a little bit shorter, but I think that the role of the data engineer, there's all of these funny cartoons, but my favorite one is of the data engineer kind of being the Superman holding back this crazy train coming in of big data. And I think what I guess it's trying to say is that big data is huge. It's lots of noise. There's lots of speed to it. Of course, those are a couple of the main things that make it inevitably big data. But in order for us to actually make meaning out of it, we need to be able to remove that noise and process that data into some kind of consumable format. And that consumable format is very much dependent on who we're making it consumable for. When I say we, I mean the data engineer. So first thing that a data engineer needs to do after the data is brought in, Sunil's going to get a little bit into that part of the data being brought in. But once the data is being brought in, one of the main things that needs to happen is the data engineer needs to go out and talk to his internal customers for whom he's building out this data preparation, data engineering stack. So depending on whether that's a machine learning person or whether that's a data warehousing analyst, his needs and requirements for how he'll be doing the data processing will be completely different. And that's one of the main things that his role is, making sure that he's collecting the requirements and specifications accurately so that whatever he turns back around to them is actually of use to them. And of course, a data engineer's role is oftentimes also tied into the platform that he's working off of. So this might be controlled by someone who's the data engineer themselves, or a platform admin, or a data engineering admin, however that internal admin resource is called. An inevitable part of a data engineer's role is also making sure there's an environment up and running in order to do the various data engineering preparation tasks that your internal customers are asking of you. So lots of different ways that a data engineer is a very big inevitable part of the stack, but basically the show just does not even get started without the data engineer being there.
Oh, very good. So I guess a lot of data engineering, we traditionally look at it as data engineering being something to move data for the machine learning teams. Sunil, is there anything about data engineering being used for data movement to new applications and services?
Yeah, so data engineering enables the last leg of the mile, right? We all want to do prediction and analysis, but in order to do that, you need to feed the data engineering engine, and we fail to understand the additional facets around that, right? You need an intelligence layer to feed the data engineering layer to do the processing at scale, right? Which I call workload engineering.
Right.
And once we're able to do that, we have to go and feed the data scientists or whatever their role is, to be able to leverage that cleansed data set and to be able to feed it into other additional data spaces. For example, many of our data scientists use NoSQL databases. Mm-hmm. Just because it lands in a storage area like ADLS, that doesn't really cut it, right? We have to bring it an extra mile. And sometimes a relational database doesn't do it. So we need to be able to, we need tools, not just a single tool, but we need several tools to be able to facilitate the data movement into repositories that are nearest neighbors to the user's most likelihood of leveraging a successful scenario for them to feed into their models.
Yeah, very good, very good. So I guess when we think about that data engineering environment, what are the must-have components that you want for data engineering?
That's for me, right, Chris?
Yeah, that's for you, Sunil.
Yeah, so I've been working in Spark way too long, right? And some things that were cool back then are just simply not that amazing now, right? The operational aspect of how I used to get in front of customers and tell them how to tune Spark and all that, it's just not that cool anymore. The reality is we need an easy way to consume and work with Spark or any processing layer. And that's why Spark as a service is fundamental to anything we do, right? So we need the operational aspects of, we don't always want to go back to an administrator and beg for our log files. We don't want to be surprised in production when things fail or things are slowly deteriorating. We want to know that proactive, right? That analysis. So having an entire experience around Spark as a service is important as much as Spark being a service itself.
Good. So, Shruti, are there other components that we would want to think of as part of the data engineering environment?
Yeah, sure. And I'm going to just go off a little bit of what Neil was just talking about. He mentioned proactive engineering being really important. And the tools that enable you to be proactive are some of the vital components that are best built into the platform itself that allow you to do the troubleshooting, but also give you alerts and notifications as to when something's going wrong so that you can be proactive about how you're going to do the workload engineering that he also mentioned earlier. There's a whole set of tools in terms of Safari-based stuff that we've got built into the platform. But when we talk about, I think the headliner topic that we also had today for the title of this session was productionizing data engineering workloads. That's when the need to be able to tie this into a CI/CD pipeline becomes really important and relevant. And so a part of a data engineering stack tool component list, I think I would also have to add something that enables you to also get integrated into your pipelines that you have for your data engineering processes. And in our case, it's Airflow, and we'll get into that, but something needs to be there to do the scheduling.
Right. Very good. And kind of going off script a little bit here, but we've got a good question, I think, that just came in on YouTube from Cool G. Where does the data engineer and the ML engineer, where's the data engineer and the ML engineer's work overlap? Anybody have an opinion on that?
Yeah, I mean, I've been working in the insurance industry for a long time. When I was up in Chicago, and data, obviously insurance industry is all about models, and there was always a conflict between where is there a fine line between, where does the data engineer start and the ML engineer and then the data scientist, right? We actually have three roles. That's the reality of it. It's not DE, it's also machine learning engineer and data scientist. And I believe that's important to understand is the reason why we have that new role in between, which is called ML engineer, which is a hybrid, is because of the language barrier, right? I don't understand the Python scripts and one of the models they run, TensorFlow. I really don't understand that language, but I do understand data engineering really well. So there is an overlap, right? And the way that it works is the ML engineer, in my opinion, is the glue between the two roles. To be able to understand the engineering aspect, which is where I focus on, and be able to translate that into what what essentially the data scientist wants to do.
Very good. And I think I think that was a good point, because in the energy industry, especially in retail power, we've seen where the ML engineer might actually come first to go and categorize the data, that's the different types of customers and the way their buildings are, the different types of buildings. And then they would feed that to the data engineer to go and do the work, to then go put all the data sets together to go and process them and run like for utility forecasts, that type of thing. Well, very good. So
Chris, can I provide a really quick alternative?
Yeah, go ahead.
Just because I think Sunil's, just from our pre-sales way, Sunil's works with a lot of the bigger customers, and I just happen to work with a lot of our smaller, middle-sized customers. And so what happens in my role that I see is that a lot of times it's the same person putting on the hat of ML engineer, ML ops engineer, and the Spark engineer or developer, however we're calling them. And the main difference is that they then still are responsible for integrating every single aspect of it. And the overlap that I often see is this need to understand their data really well. I mean, that's a big part of what Sunil's demo is also going to be about, how if you don't understand your data, then the whole workload engineering process that you're setting up might be not as performant as it could be. And this need to explore the data and understand it, I think, is definitely overlapping between the two aspects. But then also being able, the actual tools that we're using itself. The Spark engineering jobs are very on a tactical level. Both the ML engineers and the data engineers are going to be making use of both of those things. But the data engineer is often just times catering to a larger group of internal business owners or business departments for whom he then needs to produce his various workloads.
Great points. That's awesome. All right, it's been a good conversation, but I know everybody's here. They want to see some demos today. So, Sunil, I know you brought us a great industry use case that you actually worked on. Can you walk through this data engineering use case showing off Spark as a service and how you made this kind of intelligent scalability there?
Yeah. So, a little backdrop. There's not a lot of slides here because I want to get into it as well. But this came out of one of the world's largest oil and gas providers. I was engaged with a customer that was working on AWS EMR, and they had thousands of files per minute that they were processing. And they were having trouble with having, sometimes the jobs would run for 5 minutes and eventually they would skew over and run much longer. And there wasn't a lot of rhyme or reason, in their opinion, to why Spark wasn't performing the way that they anticipated. So one of the things that when myself and a couple other engineers, when we dug into it, we constantly heard the customer say it auto scales and dynamic allocation. And that, in my opinion, created an incredible amount of noise without actually thinking about the workload side of it, right? And actually, I wrote an article about this. It's right here, the tiny URL, and it goes really deep into the anti-pattern of kind of putting your horse blinders on and thinking that, some of the disciplines around workload engineering don't apply when your engine, like Spark, auto scales and there's dynamic allocation. That's a problem. And I think the industry's created this problem, and maybe we've done that a little bit too ourselves, if I'm going to be honest, right? Auto scaling is just such a hot buzzword. And when you think about it, we used to be very good at looking at our workloads and engineering our workloads and saying, okay, we're going to allocate so much memory and allocate so much, resources to it. But when it auto scales, we still continue to see these often concomitant errors. The out of memory error. Any engineer on this call probably knows that is the one that we all absolutely hate. But there's a couple of others that are naturally occurring. And we start to ask ourselves, why? We brought the hammer, we brought auto scaling. And the other issue is dynamic allocation. So what I realized in this engagement with the customer was that they had, again, the auto scaling is just supposed to auto scale, right? Add nodes. You shouldn't have to think about that. And then what about dynamic allocation? You shouldn't have to think any longer about how much memory or CPU you need to allocate to a job. And that's terrible. You absolutely cannot go down that path. And the reason we recognize that is when we started to peel the onion, we saw that, for example, a single Spark job, and this is a little bit of an oversimplification, right? But what we found is a single Spark job where you want to process many files and they're heterogeneous. Dynamic allocation is going to do its best job of saying, okay, how can I process this workload? And it's going to give you the top end, right? It's going to say, hey, I see a 2 gig file. Even though I do partitioning, I still need to give it top end memory. And so we're doing this like one size fits all because we think auto scaling and dynamic allocation we don't have to do the workload engineering. The reality is this particular use case, when we took away the 2 gig file and ended up processing the smaller files, the runtime was a few minutes, and then the bigger file took significantly longer. So we didn't have this like impact the world, fail the world action. So through that, with the customer, we found that the design principle to really make auto scaling and dynamic allocation and Spark as a service, right? It doesn't matter what you use. In order for it to work really well, you need proper dichotomization and decoupling of the service layer. Now that's a lot of words, but in simple form, what that means is when you see a workload, think of that workload as how do you bring that into smaller pieces of work, right? Don't bring the hammer. Don't always think that what I used to do too, right? I've been a victim of this. Just throw it at auto scaling or dynamic allocation. I take a workload and I say, how do I make it into smaller units of work? So in order for you to do that, you have to do workload engineering. There's no way around it, right? There is no silver bullet here. And how we did this in this particular use case is we know that data comes into ADLS or to S3, and both storage engines have tightly coupled event triggers. AWS has Lambda, and Azure has Event Grid. And what it does is it does a fantastic job that when things land inside of those storage engines, we know because it'll trigger and it'll tell something downstream, I've received these files. So that component is well known. I don't need to demo that, right? The Azure folks, everyone knows that works really well. The piece is after the file lands, let's say that there's 1,000 files that landed in ADLS. What do we typically do in that scenario? Well, I've seen two patterns, and these, in my opinion, are anti-patterns. You take those 1,000 files and you throw it at Spark and allow Spark to do one job and crunch through all of them. I absolutely disagree with that approach. And then the other approach is, and I've seen them, is, well, let's then do significant decoupling. We'll just create 1,000 jobs, one job per file. And then from an operations perspective, that gets completely out of control. So we have to have some sort of intelligent defragmentation that says, hey, what if we don't do that? What if we go somewhere meet in the middle? So what we've done essentially at the customer side, and we did this at large scale, and I call it unreasonable scale, is that we took the files, instead of taking 1,000, we grouped them and said, what if we create 10 jobs with 100 files each? And that where the light bulb went off, and we threw that at Spark, and boy, it went unbelievable, right? It processed the files incredibly intelligently. We still found a defect with that defragmentation. So one, we took 1,000 files, grouped them into 100, created 10 jobs. But then we still found that some of those files that we're processing were heterogeneous in file size. So you saw the slide I had earlier where they had that 2 gig file, in between a bunch of 5 kilobyte files. Well, what we did is we added an additional intelligence into it, saying, listen, why don't we go and tell the files that are outside of the normal distribution in terms of sizes and go and create a Spark job just for that, so that then dynamic allocation doesn't have to over allocate memory because of one large file and everything else is super small. So this is how we did the intelligent defragmentation. And what made it very easy is that we just ended up taking those groups and calling Spark. And I did not want to write Spark submit. I wanted to use a REST interface. I want to be able to write a job with how many files I want to process and just call a REST API, and magically Spark takes that and accepts that payload and moves on and does the processing. And essentially what we've done here. So the first part of what you're going to see in the demonstration is pretty simple. Data's already landing in ADLS or S3. In this example, I have S3, but it doesn't really matter. And data's in Lambda or Event Grid have created a trigger which has the metadata, not the file, but just the metadata about the files that have landed on ADLS or S3. And Cloudera Dataflow has accepted that because Cloudera Dataflow has many RESTful APIs, and we sent that metadata over to NiFi. Once NiFi receives those files, this is where, in my opinion, it's not magical, but it is kind of magical to see a massive problem be able to decouple it and solve the challenge. What we did here in the intelligent defragmentation is do essentially that. We looked at the files, we grouped them into like file sizes, and then we took some of the bigger files and we're going to give them their own Spark job. And the observation is that in that scenario, if you do this intelligent defragmentation, you get to auto scale unbelievably, and you get to use dynamic allocation for the purpose it was built for. And then there are going to be scenarios, and we found this through our testing and our research, that dynamic allocation does not always work. And if anyone that's used Spark Streaming, you should be nodding your head saying it absolutely does not work. And I agree with you, right? So dynamic allocation is not the end all be all. And there are times when we together as engineers can create some arithmetic around, maybe we don't need to depend on dynamic allocation. We can go and tell the engine, here's the amount of compute we need. So we're going to demonstrate that. And the ease of this is that all we have to do is create a JSON payload, send it over a RESTful interface, and Spark receives that. So let's get into it. So this is my Spark service, right? On Cloudera Data Engineering. It's Spark as a service. I'm not going to go over all of this. If you haven't seen this, maybe Shruti will cover some of this. I'm going to get right into what we did at the customer site where they had trouble with EMR and they ended up using this service because of some of the challenges we overcame. So I'm going to go and look at our jobs here within our service. And the job that I'm interested in is something called My Spark Job. And my Spark job is the one, again, the name is not that intuitive, right? My Spark job, not creative, I should say. My Spark job, I'm going to click into this and I'm going to look at the configuration. And you can see here that in this demonstration, I'm simply using this job. Here's the application jar file. I uploaded it to this service. And then here's the main class. And here's the arguments. And then some of the parameters, right? So, how many drivers and executors you need to run with. The piece that's incredibly important is that in these two parameters, arguments and executor, and the bottom here, executors, drivers, I don't want to set this consistent. I want this to be done at runtime. I want to set the arguments at runtime, and I want dynamic allocation to take care of this nonsense. But there are times when I don't trust dynamic allocation, so I'm going to tell the engine, Spark as a service, which is CDE, what it needs to go run with, right? Because I believe my arithmetic does trump what dynamic allocation can do. So the piece that's important is, I talked about earlier, I want to set this at runtime, but I want to call a REST API. Spark does not have a REST API, right? It doesn't come with that. It's you run your job through Spark Submit. So what we did here in this particular, how we implemented this at the customer site, is that in every single virtual cluster, Spark as a service, CDE, comes with its own REST API. And this is what it is. It's the jobs API, right? You take this API, and now you just send it a JSON payload. What job you need to run, what are the parameters, and that's it. This service accepts it and then runs your Spark job. And we're going to show that in the demonstration. So I'm jumping to Apache NiFi, and we're going to get back to the job screen, but I want to show you the intelligent defragmentation. I'm going to scroll in because I know that it might be a little bit difficult to view. So as I said in the beginning, we already have S3 or ADLS that drop the files we already have files dropped into ADLS or S3. It doesn't really matter. And the trigger send the metadata to Cloudera data flow, which is Apache NiFi. So here in Apache NiFi, I've already received, for time's sake, I've already received 31 files, right? Let me show you just to prove it. You can see here, I'm going to scroll in a little bit. I know it might be hard to see. So here's 31 files, and I can click on any one of these, and you can see that this is the file name. This is not the actual file. It's just metadata. The event grid or Lambda sent NiFi the location of the file that was dropped. And the objective is we want to go process these files, right? So now that we've arrived at having these files, let me back up a little bit. It's just a little too close. So now that we're here, we have 31 files to process. What is the knee-jerk reaction we do when it auto-scales and it has dynamic allocation? Just take 31 files and send it over to a Spark service, right? That's wrong. What we found is that here in this scenario, we want to take a look at, hey, what are the file sizes that are coming through on ADLS or S3? And in this scenario, I have a simple file router where I look at the metadata and say, how big are these files? And I've determined that 30 of the 31 files fall within the normal distribution of, like, let's say 2 to 5 kilobytes. So let's go and group them together. And I also have a single file over here, which is larger than the normal distribution, and we should go do something else. Okay? And we'll go in the right swim lane in just a moment. We'll focus on the green swim lane and see how this looks. So I have a typical file size. What is now the knee-jerk reaction? All right, we've done it, right? We've looked at the intelligent defragmentation, we looked at the file size. Now let's just throw 30 files at Spark. No. What you can do now further in terms of intelligence is group them. Remember I gave you the example where we have 1,000 files at the customer site, and we took them and said, instead of doing 1,000, we'll group them into 10 jobs, 100 files each. That's essentially what we're doing here. We're taking these 30 files, and we're saying, you know what? Go and give me a grouping that makes a lot of sense. And I'm going to go ahead and start this processor in NiFi. And you can see here that immediately I have 6. So I went from 30 to 6, and I'll scroll in just a little bit in case you can't see this. And now I have 6 groups. We did not lose our files. All we did is we grouped them in a manner so that now that's 5. We have 6 jobs that we want to send over to Spark. And each one of those 6 jobs has 5 files each to process. let's take a look at what's inside of each one of those payloads. So I'm going to go ahead and open up a single job, and you can see here, nothing fancy. Here's one job. I'm sorry, excuse me. Here's one file. I'm going to highlight that. And there's another file. Essentially, there's 5 files. So each one of these payloads, all 6 of these payloads have 5 files each. So we did that intelligent defragging. And I'm going to go ahead and start this processor because now I am ready to send this over to Spark as a service to start processing. Let me show you what this looks like before it gets sent over to Spark, the Spark RESTful service. Each one of these payloads, again, same thing, right? We have 6 payloads. Excuse me here. I'm going to go ahead and refresh my screen. My VPN might be a little slow. Just a moment. Here we are. So I'm going to take a look at the payload. And this is a simple JSON payload. There's absolutely nothing fancy about this. You remember I showed you earlier, my job was called my Spark job. That's it. This is my Spark job. And then the arguments, it's just 5 files, right? Remember, I have 6 payloads that say what job I want to execute and what files do I want to execute. I want this to be completely dynamic. Notice how I did not set any executors, and because I believe in this scenario through my testing, dynamic allocation does a fantastic job because I've ended up doing some normal distribution, found a normal distribution of file size and said, go process this together. Dynamic allocation works really well there. So now let's go on to, before we kick this off to Spark, let's go back over to the big file, right? We'll process this together. So in this scenario, I recommend that if you start to do intelligent defragmentation, what we found at the customer site is don't go and try to do this first. Go and allow dynamic allocation to try and see if its intelligence is smart enough to go and give you the right number of executors, the right memory, it's over allocated. In our scenario, we found that dynamic allocation for some of these use cases was absolutely awful. So we had to think of another strategy of how do we right size everything. And in this scenario, we took the big file and we created some arithmetic around it. So I just basically said the file size times some arithmetic. And that gave me the amount of memory, the amount of CPU, the number of executors. And we can have a sidebar conversation. I've done this at thousands of customer sites of creating arithmetic around right sizing a job. And that's essentially what we're doing here. I'm going to go and kick this off. And what will happen is it went ahead and ran the arithmetic. I'm going to show you what the payload looks like. I showed you what the payload looks like for the small files. Now what does the payload look like for the large file that we need to process? Notice it's the same thing. It's called my Spark job. And I have an argument, which is this one large file. This could be many large files that are within the normal distribution of the large files, right? So 1 to 1.5 to 2 gigs, but you don't want to be you don't want to be processing a file that's 2 gigs along a file that's 5 terabytes. That's not normal distribution. Your distribution's off, right? When it comes to Spark, your distribution is definitely off. So in this scenario, I told it what file to go process. And oh, by the way, in this, I also talked about we did our testing and found that dynamic allocation did not work. So I am telling it at runtime based on some arithmetic. And again, I'm not a data scientist, so my math isn't that complicated. It's simply telling the Spark as a service how much memory, how many executors, how much CPU we need. Super simple. None of this is difficult stuff. Once I have this, what I simply do, now that I have both jobs, I have 6 over here and I have 1 over here, I want to simply call Spark. So what do? I've been an engineer my entire career. What do? We write bash scripts. Inside the bash scripts, we have arguments, $1, $2, and it's a whole bunch of nonsense. What I want to do is just call a REST API and give it a JSON payload. And I want Spark to go figure that out. And that's essentially what we did with Cloudera Data Engineering. So I'm going to call this REST API right here and send it to JSON payloads, the 7 that you see here. So I'm going to go ahead and kick this off. And what this will do, again, it's calling Spark data service. It's done. And if I go back to Cloudera Data Engineering, which is right here, you will see that the jobs are starting to kick off. And you can see here, I'm refreshing my screen, and you will see a total of 7 jobs. 1, 2, 3, 4, 5, 6, 7. All 7 jobs have been submitted to Spark as a Service, Cloudera Data Engineering. I'm going to go a little bit deeper into this. So you can see here that this file, this particular job, was only allocated 1 gig and 1 driver core, and this particular job was allocated 2 gigs and 4 cores and 5 executors cores. The reason why is because the most of these took on dynamic allocation. It did a good job. It knew exactly what it had to do. But this particular job, I set that at runtime. So let's go look at the one that dynamic allocation took over. I'm going to go into the configuration, and I'm going to take a look at it and say, okay, this particular job, remember, I did not want to set this anywhere. So you can see here all the files were set. Whatever was in the JSON payload is now available here. And oh, by the way, there might be something wrong. I can just go into the log file. Remember I talked about operations? I do not want to talk to, I love the admins. Any admins on a call, I love you, but I don't want to talk to you when I'm doing my data engineering workload. I want to get access to my files, my logs, without going and doing K-init and trying to figure all that out. I want everything right here. And then I want my own Spark UI as well. So this one didn't complete yet, but once the job is completed, it will say, here's your Spark UI. I don't want to go to anyone for my access. And oh, by the way, over here, this will also tell me if I over allocated memory, if my data was skewed. You can click on the analysis tab. Shruti might take care of this later on, but there's a lot here that we're just not going to talk about. Strictly what we did here is we looked at the job, we decoupled, we defragged the job into smaller units, and then we leveraged some of the core capabilities of auto scaling and dynamic allocation. And over here, this particular job, you can see here the same thing. This one was that 1 big file. And then this 1 big file I set at runtime because I run some arithmetic. So this piece, again, just going back to what we did so far, we took the payload dropped in ADLS or S3. We used a native service like Lambda or Eventgrid to go and tell Cloudera Dataflow, here are the files. We created an intelligent defragmentation layer. And then we made it super easy for our customer that I was working with by not having to write a bunch of bash scripts. We just call a REST service to go and execute a bunch of jobs. Now we are auto scaling well. Now we're using dynamic allocation well. And then the last thing that came up was, Sunil, we're doing all this defragmentation, but from an operations perspective, isn't that difficult to track? What if we want to go back and reprocess one of those jobs? Where do we find that, right? And this is where we're using Apache Kafka. Every single payload that we are sending over to Spark as a Service, we also, in this implementation, you don't have to do this to the broader audience, you don't have to do this, but the customer said, I want the ability to go back in and look at every single JSON payload. So what we did is we leveraged Kafka, and this is the Kafka dashboard here. Again, we're not doing a lot of deep dive into this, but I'm going to click on the CDE jobs. This is the topic that all of our data was in. And in this scenario, you can go back in and take a look at every single JSON payload that was sent over to CDE. We store that in Kafka as well. So if you want to reprocess a job, or you're looking at a particular job and it failed, yeah, here it is. Take a look at this. For example, and I'm going to scroll in just in case you can't see this. This should look all familiar to what we just saw a few minutes ago. This is my Spark job. It has all the files that I want to process. It's not rocket science. But the customer, this particular customer, wanted to not go back and go figure out what the JSON payload looks like. They wanted to just have everything stored in Kafka. And if they got to go reprocess something, or let's say that their code did something that wasn't expected, they want to redeploy their code in a CI/CD pipeline and then plug back into Kafka to go reprocess their jobs. And they did that by storing all the JSON specs. So all we have to do is now consume these JSON specs, send it over to Spark as a Service, and they can reprocess, right? We made it, well, they made it super easy. This wasn't our idea, so I can't take any credit for it. So in summary, demonstration was we took data, created an intelligent defragmentation, going back to what we did over here, created an intelligent defragmentation layer by doing workload engineering, also looked at additional how big the files were, and then we sent it over to Spark as a service through a RESTful API. And we allowed for an operational control that if anything fails, we can go back in and replay those events from Kafka. Does that make sense, Christian Shruti? Any questions?
There you go. Yeah, hey, Sunil, that was great. Great solution. I really liked how you showed with a bit of planning up front, you could take a more effective approach to scaling jobs in production. What challenges did you encounter as you moved this from development to production?
Yeah, so there's two issues that glare out at me because I work very closely with our professional services organization. One was the behavior of trying to teach the customer that workload engineering is important. We can't get away from that, right? I think a lot of the marketing material, and this is nothing against marketing folks, but a lot of the marketing material around auto scaling makes data engineers like myself believe that we don't have to do our work anymore. We just throw it at some engine. And that was hard to change that paradigm. Unfortunately, it's become that way. We don't think we need to do that work anymore because of SaaS services. And even with a SaaS or a PaaS service, it's difficult to teach people that even though we're in a new world of making things much easier to use, we still have to adhere to some disciplines, which is workload engineering. The second piece, which is a little bit more tactical, was that the customer bought into, and again, this is nothing against Amazon EMR, but when we brought that over, we are an open source stack, right? We're Apache Spark. When we brought the code over from Amazon EMR, we had to find out that they had to go and do a bunch of changes to their code because they were using proprietary API stuff, right? So that was a challenge because they did invest a lot in some of the proprietary solutions. And then going back to open source was a little bit challenging. So they had a lesson learned: stay close to open source, don't buy into the proprietary APIs, and then you're in control. You can move your code anywhere you want.
Very good.
And maybe really quick, Sunil, I don't know if I just missed this, but I was thinking of the impact, the difference that the workload engineering made. Do you guys have some clear breakdowns as to what kind of a difference that it did make for your guys' flows? I'm not sure if I missed it. I'm sorry if I did.
That's a good softball pitch right there. Okay, so we were processing. This is really cool. They were processing 9,800 jobs per day, and it took them 2 clusters, and it would take them 24 hours to do the 9,800 jobs, right? What we did, because we did the intelligence, and again, it wasn't because the engines like EMR, they're bad. It's just, one is they weren't using good disciplines. So we were able to do the intelligent defragmentations that take 9,800 jobs, compress them down to roughly 3,000, and we were able to process that in 7 hours. So that was a massive cost savings to them. And the other thing that they found, which was a side effect that we didn't anticipate, and by the way, I was a part of this too, so I can't look like I glorified this. I over allocated memory when I was helping the customer, right? I ended up doing roughly 16 gigs executor sizes. Safari, which I think you're going to be talking about possibly, told us that I way over allocated memory. So that was an awkward moment with the customer because I'm supposed to be the expert. But that we did use a lot of tools. Not only did we optimize the runtime, we also found out that I was over allocating the jobs.
And a really quick follow-up question on that. First of all, awesome that it did go from something like 24 hours to 7 hours. And this is something that I've been thinking about more because of this whole sustainability topic, because we think about cost reductions, definitely great. And then the sustainability aspect comes in just hand in hand with it. When we're being optimally using our resources, we're also being sustainable. So the follow-up around this is then when we went from 24 hours to 7 hours that it took to do the jobs, was it compressed into like a clear chunk of time, or was there still some peaks and valleys that you guys saw in that processing?
Yeah, it definitely. I mean, 7 hours was the average. We found out that it burst up to 12, and some of it actually was down to 3 hours. So yeah, it was 7 hours isn't a hard figure. We do have between 3 and 12 hours. What we did find out, which was another side effect, was that the customer was maintaining 2 different clusters. because we were able to decrease not only the runtime, but the amount of clusters that they had to go manage down to one Spark as a service offering, that also was a cost savings estimate. So we, again, the numbers are highly interesting when you talk about 24 hours times 2 clusters. Now you do 7 on a single cluster. We really kicked butt on that use case.
Awesome. Thank you.
Very good. So, hey, we've got a question from the audience. This one's it's off of YouTube from MC Cat. How did you know how to configure allocation for the given jobs? Was there a methodology you kind of took to think through the way you would configure it all?
Yep. So
was it trial and error? Was it yeah.
Well, no, I mean, it was more in trial and error. I mean, obviously, some of it has to do with experience, right? I don't want to come up as I know everything. But reality is I've worked in the industry for so long. What I've realized is that very similar to MapReduce, all these engines have some sort of, first, I want to go back to, you want to leverage Spark's dynamic allocation. You want to fail fast with that. Don't over-engineer. What I showed you, don't start with that. Don't go and try to figure out the arithmetic, right? Keep it simple. But you will notice that when you run Spark, when you run your Spark job, go to Safari or go to some workload analytic that tells you, are you over allocating memory? Did your executor run too long? Were there too many states in the pending in the DAG? That will tell you a lot about your workload. And then you can say, you know what? Dynamic allocation, I no longer trust you. Then you start to do some simple arithmetic that we've done using MapReduce, right? Which is take your file size times X amount of X coefficient, right? It's pretty simple. In fact, I wrote a blog about this and we can share that. But it's pretty simple, right? The things that we learned in MapReduce, we take the same principles and we apply it to Spark. And that's how I came up with the configuration. But it has to do a lot with trial and error as well. There's no exact science.
Yeah, and see, you actually had a phrase there that I really, really like, especially when we're moving to the cloud and we've got this ability to be elastic. It's that concept of failing fast. And I think, sometimes, the nice thing about the cloud is we can jump in, we can start this, spin up an environment, do our work, and then drop it away. And, that concept of fail fast allows us to iterate faster and get improvement faster. I think it's a great point there. And when we talk about Spark as a service, just for everybody out there, we're talking about Spark, spun up as a virtual cluster with Kubernetes underneath it. So that allows us to, quickly spin these things up, do the work, and then kill it and let it go away, and we stop consuming at that point. So great. I really like every time I hear somebody say fail fast, I'm like, yes, we're getting it now when we move to the cloud. Awesome. All right, so Sruthi, I guess let's jump over to your part of the presentation. What tools and processes can we use to optimize these workloads?
Yeah, so first of all, I think my screen is now sharing as well. Okay, cool. So I'll answer the question, Chris, and then I'll kind of hopefully walk through that in the demo aspect too. But some of the main tools and components that are necessary are, as mentioned in the earlier conversation, a platform that's going to be able to use the power of the cloud and quickly spin up and spin down resources. Just following up on that last thing that we were just talking about failing fast. You're not able to do that in a traditional data engineering environment when you're thinking about this on premise, where you have to first ask for resources to be made available based off of your understanding of the internal customer's resource requirements. So this is a multi-step phase that we kind of get to skip over because we're doing this on a easily scaling environment. That's one of the platform parts of the tools, and then we'll get into the troubleshooting parts that are those are really the tools that Sunil was also using to go back and figure out some of these configuration steps and do that trial and erroring a bit faster and help the ways that he was able to read the charts to able to determine what exactly he could go back and change in the next try around. And then, as we mentioned, the CI/CD parts. So I will hopefully get started here and kind of going to walk through this in the same sequence of events that we spoke through about this. First, most important thing that we need in order to be able to do these data engineering activities is the part catering to the data engineering admin. And this goes into the platform creation setup phase. So within our tool, so you guys already saw a little bit of this from Sunil's use case specific version. And now to kind of look at it a little bit longer into the specifics of it, I'm interacting with this specific CDE or Cloudera data engineering service here. And the way that this is set up is that I've given it, I see here that 2 nodes are being used of 50, and there's corresponding memory and compute that has been allocated to it. This data engineering service itself, I mean, one of the main differences that we have to think about here again on cloud as compared to the traditional way, this is no longer Spark on Yarn, but Spark on Kubernetes. So this is a Kubernetes cluster that's been spun up on command for this data engineering specific exercise or set of exercises. The way that we imagine you or encourage you to work through this environment is by, for example, let's try to set up a new data engineering service. Let's say that we have a couple of different workloads, use cases for which we need to do this. What I'd go and do is give it an environment name, right? Giving it the data engineering service itself a name. In this case, let's call it FOD for future of data. And then I pick the environment that I'm going to use to access. In this case, when I say environment, what I'm referring to is the cloud environment that I'm going to be creating this Kubernetes cluster in. By tying it to this environment, I'm also tying it to the data lake from which I then can access and also push data into. So bidirectional, of course, and this means that every reference that I make from the Kubernetes cluster to the various data sources is going to happen with this referral that I've made to the environment that we're working from. The environment itself, the Kubernetes cluster that you're now creating for your data engineering service, it can be completely spun up based on your requirements as to what types of instances that you want to use. This, again, expects a little bit of homework to be done on the data engineering platform admin side as well by having an understanding of your data and your workloads in order to determine what the optimal instance here is going to be for you. This throws into then 2 other factors. One, you want to figure this out so that you're making the most use of your resources that you're actually choosing from this list here. And then also because when you're optimally configuring the service type that you're going to spin your cluster up off of, it means that you're going to optimize the amount of resources consumed and make sure that you're not having any resource constrictions happening because you haven't given it the right sized servers. So the workload instances servers themselves are coming up just based off of whatever cloud infrastructure you're using. In this case, whether it be a AWS or Azure one, doesn't matter, but that's the kind of service behind it that we're using here. An important part to note is the auto scaling part. Whenever you determine how big you want your cluster to actually be, you could choose to also make sure that you always have a set of warm instances ready to go for you. So if you know that your workload, again, based off of your intimate understanding of your workloads, is always going to be at least several instances worth, then you might as well better off making sure that you have no wait time before you start up your CDE service. And then again, to the cost consumption part, you also have the option to choose whatever type of spot instances you want. These are usually 90% less on cost basis than the typical on-demand servers that you might have. So very much worth understanding, and you can specify within the spot instances part exactly how much you want to have in terms of the auto scaling amounts for that as well. So same thing between the various cloud providers for this. So the flexibility is there. And then once you hit CDE service run, all that happens is the cloud service provider themselves spins up this infrastructure for you and enables you to have your data engineering cluster up with 50 odd nodes of your chosen size in a matter of 30 to 45 minutes. So depending on how many nodes you're asking for and the delay in your network, et cetera. So now that we've got a data engineering service the Kubernetes platform that we can use to actually interact with and submit our jobs into. The next important part is that we're probably going to have multiple different data engineering use cases for which we want to create infrastructure and allow the users to come in and submit their jobs into. Sunil gave the example of one specific use case. There's multiple jobs, of course, are a part of that or a component of this, but the use case itself had a specific set of goals in mind, whereas this expectation for our data engineering service is that you are likely going to have multiple different virtual clusters spun up within this allocated 50 nodes for various departments or other internal use cases for which you want to create your set of resources that you make then available to the data engineers that can then come in and access their specific virtual cluster that they know is relevant to their specific use case. So quick click through of this, the virtual cluster spin up, because it takes only a matter of a couple of minutes as compared to how long it takes to spin up the data engineering service itself. Give it a name here. I'm going to call it really simple test. I'm not very creative with this, so sorry about that. And the CDE service that we want to use is, of course, the one that we were already pointing at and looking at. And in this case, instead of setting the number of nodes that you want to have as your base threshold, what you're doing is creating guardrails and saying that this is the maximum amount of compute and memory resources that you want to allocate to this specific virtual cluster. You then even have the chance to specify if you want the drivers and executors to run on the on-demand instances or spot instances. And because we have the option, and this current data engineering service that we're using also is created with both in mind, I have the ability to go in there and choose. So I'll just keep the default here and the Spark versions. So important to note, of course, the fun part that we're coming out with is the technical preview. We're already on the pipeline for Spark 3. So Kubernetes cluster means that every single virtual cluster can be running on a completely different version of Spark. So if you want to experiment with Spark 3 on a different environment within the same 50-node Kubernetes cluster without impacting any other workloads or use cases, then this is exactly a perfect instance or example scenario in which you would create a virtual cluster just for that specific purpose. So let's keep the basic one here, and I'm going to hit create cluster and let that continue. If you'll note at the very bottom, actually, I can click into it just 1 second to show this example. I also have the ability to say that I want to restrict access to this virtual cluster. This is for the example scenario that you're going to have users that are, and data engineering users that are going to come in and access these virtual clusters that should only have access to a certain set of resources that's available in one specific virtual cluster. And I can do this by therefore saying that for this virtual cluster that I'm now creating, I only want Sunil, for example, to be able to have access to this. So I would be viewing this here on a per user basis. What's coming up shortly for us is also a group-based restriction of access here. And this is all tied in to the users that are already synced to the environment that we have chosen, the data lake that corresponds to this CDE Kubernetes cluster that we're creating. So the beauty of CDP really comes into the fact that all of these various parts are integrated. So we'll have to make sure that that all is taken into account. So I'm gonna click back and cancel. We're gonna go back into our initial cluster, which is this virtual cluster here. And we already see also the jobs that Sunil had spun up that are running here. And one of the things to note is the baseline is the amount of CPU when there's nothing going on in the clusters. There's a flat line, makes sense. And whenever we have some action going on, we see this natural graph chart giving us a direct visual of the amount of resources being consumed. So we see that little sidebar near it also telling us the exact amount. One thing that I want to point out here before we slip into the other thing.
All right, I guess we had a little bit of technical difficulty there while we wait to get Shruti back. I guess one of the things I saw and what Shruti was showing us today I'm seeing that the toolbox for data engineers is starting to grow outside of the SQL space to include programming languages like Python and Scala, and also some of the DevOps bits that you talked about today, Sunil. What do you think about that? Did I lose Sunil? Oh, okay. All right, good. Well, let's jump. We have a little bit of technical challenges here right now. So I think one of the questions that I saw popping up was what were the run times for the two approaches that Sunil had shown? And with those, I believe the previous approach was a little over 20 hours with just straight EMR, and the defragged approach that Sunil was showing had gotten it down to just under 7 hours, and that was our friend Cool G out on YouTube that had asked that. So Sunil, I'd ask a question about kind of showing the different skill sets of the data engineer. Do you have any opinions on that and where DevOps now comes into data engineering?
Yeah. So, I mean, look, I'm not a DevOps geek, but the reality is when I'll give you the customer what they wanted, right? When they worked, they were a legacy on-prem customer, and we heard a lot of user stories about where it was very difficult for them to build a job and CI/CD. In fact, the lead architect on the call basically said Cloudera and Spark and DevOps and CI/CD is an oxymoron. And so I took a little offense to that. But the reality is there is some truth in that, right? The DevOps around big data and how to operationalize this isn't easy. But what we did observe is that for novices like me, okay, that know Maven well, but I don't know DevOps and all the other aspects of it, we were able to leverage Spark as a service, CDE, because of the way that the service is deployed. We leverage the native storage like ADLS or S3 to place our jar files inside of, so that when I build my code, which I'm really good at building code, I can go and part of my Maven repository, Maven step, I can go and deploy my jar over to S3 or ADLS. And the next time the job runs, it automatically picks up the changes, right? So to me, DevOps, we made it easier by being able to deploy this RESTful API interactivity with Spark as a service, because before it was just darn difficult to get that working.
Very good. Okay, that's great. Yeah, great. I think those are very good points to it. I think, DevOps in data engineering is becoming a bigger and bigger deal. And I see more and more people, especially data engineers, having to get into the DevOps side. All right, we've just got Shruti back. I know this is kind of a transatlantic meetup today. And we're going to go ahead, and once Shruti has her screen shared, so there we go. Let's jump back over and let Shruti finish her part of the presentation. Shruti, go ahead and jump back in for us.
Thank you. Okay, so I think I am on screen and being heard and all of that now. So I am going to go through this a little bit faster than before, just for the sake of time. But I believe that I was just at the part where we had gone through and shown what it looks like to restrict access. I hope it wasn't too much later or before that I had missed. But what I was talking about is the number of cores consumed that you see at the very top. And I wanted to point out that what you see here in cores consumed is the difference between what's actually consumed versus the next part, that you're also able to have multiple different visuals as to the consumption of resources. So one of the other visuals that you get through the data engineering platform here is the Grafana overview. And you'll be able to quickly see the number of CPU requests that are happening. And in case that CPU request is greater than the amount of cores actually allocated to the cluster itself, in this case, the maximum that we see here being asked for is a little over 25. And in the cluster itself, we see here that there's exactly then a little bit under that used, but we have allocated 200 cores to this, so that we're in good shape. But just wanted to point this out because I have seen this in other situations where you underallocate a virtual cluster trying to optimize your resources, but the troubleshooting aspect of the platform that's really of benefit and kind of comes in clutch in this situation is exactly then when you're able to flip into your other visual like Grafana here and determine all of the various ways that and directly look into all the ways that consumption of resources is being handled. One shows you actual used, other one actually shows you the details of how much is being asked for as well. So we went through also this other second virtual cluster creation. We talked about how we now have a test one running on Spark 3, whereas this one here is running on Spark 2.4, completely different workloads, but still using the CDE 50 node service that we've created on a single Kubernetes cluster. So that's all still in play. Now we're going to go into this cluster itself and look at some of the jobs that have been spun up. So we're going to see if, when we jump into this, first all the list of Sunil's jobs that he just triggered off with his part of the demo and showing you all the various consumption of resources happening in that way. But the part, and yeah, exactly. So we see the various runs and the succeeded and not, but the job that I actually want to kind of get in more into the detail of, because I want to show you guys at least a few minutes of how Sunil got to the phase of his analysis, trying to determine how to best configure the right number of executor cores, memory, etc. So the one that we're looking at here for this is actually this job called Bing COVID TOS 3. And the duration of it is pretty clear. There's been all of these various different runs of it. And then in the analysis part, this is where it gets interesting because I hope my screen is big enough. I'll make it a little bit bigger for every one of us here because this is all written indeed pretty small. So we're able to have a full overview of a lot of the different things that are going on within this job itself. I think I need to make it actually a tiny bit less big to show the number of stages here involved because each stage has a certain number of different tasks involved, and that's all going to be relevant to determining the performance and tuning the performance of the Spark job here itself. So these are some of the details that are a bit more useful in terms of helping you understand and read what's going on beyond what you would be able to see from just your Spark UI. I know Sunil started off with saying that because of his depth of experience, what he immediately wants to see as a data engineer is the Spark UI up and running. But regardless, I think he wouldn't disagree that this process is made a little bit easier by the fact that these visuals are available. And he himself said that they had over-allocated memory in one of those first interactions with his customer, which is what led to them seeing a lot of delays. And one of the first things that one is able to see with this type of a chart is how much memory you've allocated for the different executor cores and if it's making sense or not. And just to kind of tie that into why there's the delays around running executors with too much memory allocated to it, that usually results in excessive garbage collection delays. And that's the factor that's actually causing, so because to kind of make it directly clear between why too much memory and delays are tied together, that's kind of the reason behind it. And again, Spark is beautiful, but it's also, and it can be highly parallel, but it's also not any kind of magical parallel processing system. So it's limited in its ability to figure out the optimal number of resources that you want to give it based off of also information that you're providing into the configuration of it. So all of these tasks help you do this. And the breakdown of the amount of CPU usage, memory usage, IO are the parts that are telling you how much you need to go back and reconfigure this by. And in the Spark core usage, we're seeing this line here coming up at around peaking at about 100%. So we know that we're certainly not giving this or over allocating this in any way whatsoever. And the CPU occupancy percentage also comes over this a little bit. And this is something that we can then kind of correspond back to what we were seeing in those Grafana charts. And same thing with the amount of actual executor cores assigned coming up right near the threshold. So this is the type of situation where we might consider actually allocating a little bit more and making sure that we're not running at threshold and running it too optimally every single time. But in terms of then drilling down into the part of Spark performance tuning, that's not just about how much allocation of resources you're giving it. Sometimes it's just about whether your code is well written or not. So that's where, by drilling into these various stage phases that are also shown here, you get these an analysis with a flame chart associated with it. And then you can kind of break it down into how does your code actually look. If there's, depending on the width of any of these one columns, you can go back and determine if any of these one tasks that are part of the various stages need to be optimized here in any form or way that needs to be better. But these are the types of resources, to kind of sum up all of that we're seeing here, that you wouldn't normally be able to see in a Spark UI just provided to you after hitting a Spark submit, which is all that was needed to be done in order to get these jobs running in here. That's wonderful if you're just using Spark submits, but one of the other cool parts of doing this on cloud is the CI/CD integration parts. So that's where our having a managed Airflow instance also comes into play. So as mentioned, when we say managed Airflow instance, what we're saying behind this is that inside the CDE service that we've got up and running, there is a, let me click into this really quick so we all are able to see this for the same way. When you click into cluster details, this is the same place that I come over to understand which data lake and environment my virtual cluster here is corresponding to, same place that I also use to download my CLI tool, which is also further helping me integrate this into whatever IDE that I want to use. And then also the same place from which you would click into the Grafana charts that we were looking at earlier. The Airflow UI is then also made available from here, and that's what we have up here for this specific DAG that I've been that I just have up for us to go through. But when we say managed Airflow instance, this is something that typically we see at other customers that they have to spin up and take care of and monitor all themselves. Whereas in this service, every time you have a DAG, all you have to do is upload your custom data that you probably already have for your various data engineering pipelines. And it's then incorporated into the CDE service as a resource, which is, you have the different formats of types of ways that you can interact with this cluster. One is by creating new jobs. Another is by creating resources such as the Airflow tag that you can then use to automatically trigger your various workloads and Spark jobs here on the fly. Or sorry, not on the fly, but in a scheduled manner. And also with the CLI compatibility and the RESTful API part that's also tied into this. That's what Sunil was showing in his demo that they used for being able to trigger the jobs into being run directly in CDE from an external place. So all of those triggers that are then possible and being submitted in here, that's a form of being able to do first the CI validation part of your code that you're submitting, and then actually also triggering the submission and deployment of those jobs as well, so that when you have this ready to go, that's all happening in a synchronized format. The Airflow DAG view itself with the UI, when you jump into it, you're able to see it exactly as you would in your typical separately managed Airflow instance, and then get into all of the details to determine if there's any task durations where you see that it needs to be a little bit monitored and come back and there's a cyclical loop that's happening, etc. Airflow for those that have been working with typical just cron jobs instead is probably a likely alternative that you might find to be far better, but definitely from the way of breaking down exactly the way that these jobs are being scheduled into this, far more elaborate and giving you the potential to optimize your code submissions in a far more flexible way. Sunil, did you actually use Airflow at all? I don't know if you can actually see me, but just was thinking that when you guys were triggering in the jobs, you were saying that you were using some AWS native code, but I wasn't sure if you also used the Airflow managed instance from the CDE component.
The broadcast can hear. Okay.
There we go.
Yeah, we did not. The reason why is I think Airflow for that particular use case, it was mostly singletons. There wasn't a lot of job dependencies. But once we get into more complicated use cases, when you do have dependencies, Airflow seems to be the standard. Nobody gets super excited when you say Uzi, right? I don't think any one of us do. So, Airflow seems to be a good fit for Spark workload. But for our use case, it was singletons.
Okay.
Good.
And maybe the last thing, Chris, that I would wanted to show here is that there's also the possibility when you're creating jobs to create two types of jobs. And that's the part where you could then, when you're choosing to submit an Airflow job in here, to actually add your resource, which is a DAG in most cases as a script itself, you could then choose to have all of your various jobs that you already have as a part of it being executed in just one click, as opposed to triggering them from a normal job upload of a Spark job here in this case, where you would then get into the scheduling options, whether it be a cron job or a more UI-based one. And same thing when we were talking about troubleshooting, when you actually go through the analysis and determine how you want to change the number of executors and cores you assign, instead of the typical Spark submit CLI way, another alternative to do this comes also from the UI-based version here. And for troubleshooting purposes, then exactly being able to show from the UI just exactly what level of log you want to see in your response here as well. So that's hopefully a little bit of the full circle. We jumped right into the job itself and looking at the analysis of it. But if you want to come back and change any part of the configuration or trigger a different type of Airflow-based job to be scheduling other jobs into the same cluster, then this is the same way that you'd be able to do both in one place and have hopefully all of your various data engineering needs met for the various use cases. Any questions?
Hey, that was great, Shruti. I know we had a little bit of some challenges there from technology across the Atlantic, but that was really good. One of the cool things that somebody just asked about that I think we can talk a little about is with our move to with the move from the traditional clusters in the cloud to being more leverage and managed Kubernetes. MC Cat's asking, has Yarn been dropped completely, or what are we using now in place of Yarn?
No. Okay. That's loaded. So in Kubernetes, let's set the context, right? Because answering the question without context is unfair. So Kubernetes was built for microservices and applications, right? It was never built for big data. And the reality is that it started to mature, and it created a lot of opportunities for us to migrate our workloads over our services like Hive and Spark. But there's still an inherent gap. And for example, some of the things that Yarn does really well in terms of scheduling and preemption, all those things that Yarn comes out of the box, you just don't get out of Kubernetes. In fact, Cloudera was one of the lead contributors back to the Cloud Compute Consortium to Kubernetes to go give a resource scheduler, some of the capabilities that are baked into Yarn. So one of the things that we did not talk about in this demonstration was Unicorn. So Unicorn gives you the layer on top of Kubernetes where, look, Kubernetes is amazing. It's highly durable, but it's missing a whole bunch of stuff for us to do amazing things within Spark. So that's what we adopted Unicorn, open source tool, where it allows you to do very similar scheduling capabilities on top of Kubernetes, right? So to answer your question, Yarn is not going away. Yarn is essentially a framework, and we're going to continue using it, and others are going to continue using the principles and the disciplines of Yarn on top of Kubernetes for big data workloads.
No, very good. Hey, George, there we go. That's very good. And for those out there, Unicorn it's spelled with a Y. So it's YUNIKORN for those that will be looking for it. Okay, so a few more questions are out there. And then, because I know we're starting to get to the bottom of our show here today. But one of the questions that's out there, first, yes, this presentation will be available and video will be available later on YouTube. We've also got Neil Chidhari, who's asking, since you're using a REST API to trigger, how do you handle the usual HTTP issues like failures, retries, circuit breaking, authentication, etc.?
That's good. Good question. I love that. So we dealt with that. So here's the again, we didn't get into a deep dive of Apache NiFi. I'm sure Chris is going to probably host a session, or will host it, or has already hosted a session. But to try to keep it, not going too deep. Apache NiFi, when we use Apache, the reason we selected Apache NiFi, not because Cloudera, I really don't care. Why we selected it is because I wanted it to be easy for that specific reason. API endpoints go down, right? We know that. So what we do, we are using Amazon's ELB to kind of keep it resilient, highly durable. But let's just pretend that the endpoint is not available. What Apache NiFi does is the capability, and by the way, I wrote an article on this, how you go between two different Spark as a service clusters. But how you do this is you, when NiFi calls Spark REST API, if it does not receive an acknowledgement that there is a successful capture of that payload, it will retry it, right? It has a lot of processors to be able to do that. I wrote an article, and this came from the same customer. Once we matured the design, the next evolution of this is, what if that particular service is down, right? You don't want to just have all your workloads waiting. For example, cybersecurity use cases can't wait for a Spark service to come back up, right? Let's say an AWS or an Azure region is down, you want to continue processing. So I wrote an article on it. I'll probably share it, and we'll probably add it in the deck, where you allow Apache NiFi to quarterback when bad things happen. When, let's say, a Spark as a service instance goes down, it will go and send it over to another regional instance, right? Yeah. So it's highly durable. You continue to process your Spark jobs without having to, wait for a region to come up or a service to go self-heal.
Very good, very good. And so another question, this one's for Shruti. Venkata on LinkedIn is asking, how do you usually deploy Airflow DAGs to CDE?
So I think that my screen's not showing, but so the first main way is that, so the first main way that we can do this is actually by going and looking at the resource upload part of this. I'm not sure if I'm sharing my screen, am I? I am, okay, but I'm sharing the wrong tab. So 1 second, this is the unicorn scheduler part that I wanted to show as a response to the last question. But the way you go ahead and do this is we looked at the different ways that you can upload resources into the virtual clusters. And there's all kinds of different resources that you can upload into the virtual cluster. One of them is your Airflow DAGs. So you can upload the resource in that way. You can also have your DAG be a part of your whatever IDE you're using. And when you're using the CDE CLI, you can also have your Spark, your Airflow DAG be submitted in directly from there. So it doesn't have to be necessarily via the UI, but any other way of interacting with the CDE cluster itself, which could be by way of the CLI or the API, will allow you to incorporate that DAG directly into the platform, which you can then keep submitting and reusing. On that same note, maybe it's also worth mentioning that you can add Python virtual environments also in that same way as different resources. Yeah. And have all of your dependencies catered that way. And because this is now based off of Kubernetes, you can also go ahead and customize all of your Docker containers that are being used to spin up your virtual clusters and have it be all of the dependencies and packages that you wish.
Very good. Okay, so last thing, and I think we kind of showed this, but maybe you can, is there a way to take those metrics from CDE and bring those into an external service like Grafana? Go ahead. I know we have Grafana kind of tied into it, but we can kind of talk about the Grafana part of it all.
Maybe I start with it and then I'll let Sunil complete thought. But so the way that we think of Grafana here is for the consumption of resources on a virtual cluster level. So we're talking about how many cores memories are being allocated to the various job runs, and then with the metrics that we're looking at within Safari, that's then more specific to each of the executor core memory allocations that are being done on a per task level for the Spark jobs themselves. But that maybe I missed something. So Sunil, I'll let you go ahead.
Yeah, and let me know. I mean, there could be a follow-on question, but if the question is basically the metrics that you're seeing in CDE, can they be imported out to some other external repository, right?
Right.
A lot of definitely. In fact, I'll tell you what, this customer is importing that to Elasticsearch. Right.
Oh, okay.
Well, this particular customer liked our Grafana dashboards, but they said, look, we already have Grafana pointing to Elastic. So what we actually did in this solution, we actually use Apache NiFi to go and grab the stats from CDE and then pumped it back into Elasticsearch. And then that's where they had the enterprise grade, monitoring and, how things are running and things like, and then they have Grafana there. So, of course, if the developer wants to go in, it makes a lot of sense. But from an enterprise perspective, where you're trying to feed a single engine, everything you're seeing on the screen in terms of metrics, that's all statistics we're using and available through the API.
Very good. Yeah, that's awesome. And that's great. And it's really this, we've really tied a lot of this into the API and the REST services, all of that, where it makes it very easy to integrate into bigger workflows. I like that. All right. So I think looking at my my board, that's the last of our questions. So a few resources that we have for today for everybody, and these will be available later in the YouTube down in the body of this, the description. First, we've got a couple blog posts about data engineering that I've recently published. One around airflow pipelines pipelines in CDE. The other one is around being able to accelerate using CDE to accelerate data pipelines. And then finally, one of the blog posts that Sunil was mentioning, we have a link for that in there. And we've also got a link for our Future Data Meetup page. We don't have a date for it yet, but just so y'all can be watching, sometime in November, we will be doing our next CDP on Azure Meetup. It will be about around streaming. So we don't have a date for that yet, but look for it on LinkedIn and other services. We're going to have it out there for everybody. So for everybody that came in through Meetup today, we do have a survey that'll come out. Please go and fill out that survey. Gives us that feedback's great for us. It helps us to kind of adjust these and build these out, make them better for the content that you want to see. So, okay, it's time, that time you're all come for. Hopefully it's raffle time. We got a couple prize packages out there. And so I think I've got everybody in the wheel that asked a question today. And let me spin the wheel. And the first winner is Natasha Lee. You'll be winning our first prize package today. So we've got one other prize package for everybody out there. Let me spin the wheel again. And our second winner today will be David Lai. David, you will be winning the second package. So for our winners out there, hopefully you're still with us today. You will need to send an email to claim your prize. You'll send an email to socialmedia@cloudera.com and just tell them that you want a prize today, and our team will get with you and get your swag so you can be all swagged up in Cloudera gear from here forward. So I'd like to, this concludes our meetup today. I'd like to thank the whole team. I had a couple stars here with me, and Sunil and Shruti. Great job, great presenting. Great thank you to the production team, getting everything. We had to move on the fly a couple times. But this is a great event, great questions. Thanks for all the participation out there. I look forward to seeing you all at the next Future of Data Meetup and our CDP on Azure meetups going forward. Thanks again for joining us. Bye.